I'm Anil Kumar, and in this video we'll explore how to find absolute maximum and minimum for the given function with boundary conditions. The question is, determine absolute extreme values of y equals to x minus cos x, where x is greater than or equal to minus pi and less than or equals to pi. So to find extreme values, we need to find critical numbers. Critical numbers are numbers where the derivative is 0. So let's find the derivative first. So we have y equals to x minus cos x. So derivative y prime will be 1 minus sin x. That is equals to 1 plus sin x. Now we need to find zeros for this, and within this interval the zeros are at, now you can see that is y prime. Now one thing you realize is that sin x is a value which is between minus 1 and plus 1, right? So what you realize here is that it is never negative. So that means, let me write it in clear and bold, that y prime is never negative. That is to say, I'm saying y prime is greater than equal to 0. Of course it can be 0 at these 2 points where the sin x is minus 1 sin x, right? So the idea here is that the function sin x is between minus 1 and plus 1, and therefore the derivative is never negative. If it is never negative within the given domain, it means you really do not have any absolute maximum or minimum in between the domain, right? So that's what it means, right? So that clearly indicates that we do not have local maximum minimum in between. Well, or you could see it the way that this is 0. We can say y prime, let me use, so we can say y prime equals to 0 when sin x equals to minus 1, correct? So what we will do here is we'll find the critical numbers anyway. So the critical numbers are when sin x is equals to minus 1. So that is the graph of sin x, okay, because we are considering both negative and positive. Normally we'll draw the positive side, and then this is my negative side, right? So this is how graph is, and our domain is between minus pi to pi, and clearly the function is negative 1 for minus pi by 2. All right, so we do have a critical point here. So we have a critical number. Let me write critical number as x is equals to minus pi by 2, right? So that is the critical number for the given function. Now if I substitute either side of minus pi by 2 in this particular expression, let's analyze the derivative. So we are doing it, but we have already written the result here. Let's analyze the derivative y prime on either side of pi by 2, minus pi by 2, right? So on minus pi by 2. So one value here could be 0. So we could take a test point as 0. On the other side, we could take a value which is, let us say, minus pi itself. Now what you notice here is that if I substitute minus pi, at minus pi sign is 0, it is positive, right? So here we have positive. On the other side also, if I substitute 0, sign is positive, we get positive value on this side also. So both sides it is increasing, correct? And therefore there is no change of increasing and decreasing, correct? So there is no local maximum minimum at this time, right? So what we can now do is we can figure out, the other way to say is that the function is always increasing, right? So now let's go from here. So these are different ways or thoughts about the solution of this question. Now we say that the function is never negative or it is always increasing. So think about something which is always increasing. Where could there be maximum and minimum? Well, at the two extremes, that is what it is. So let us test the value at the two extremes to find absolute maximum and minimum, right? So from here we say, since the function is always increasing, absolute extrema I should write, but I'll write now a maxima and minimum will be at the boundary. Is that okay? So we'll find the value of the function at minus pi and at pi to get the result. So first value is at minus pi, let us see. If I substitute minus pi for x, I get minus pi minus cos of minus pi, that is one value. The other one will be at plus pi. So plus pi minus cos of pi, correct? So what is cos of pi? Cos starts with maximum and pi is 0, right? So this value is minus pi minus 0, that is pi minus 0, right? So this is minus pi and that one is equals to plus pi. So that is the minimum, this is the maximum. So we have minimum, absolute minimum, right? At minus pi, and the value is also minus pi. And absolute maximum will be at plus pi, the other boundary, and the value is also plus pi. So that is how we can solve such a question. So if you get a derivative which is never negative, then absolute maximum minimum will be at the boundary only. I hope that helps. Thank you and all the best.